Kevin Lee here, intern at Solve Systems. Today we are going to deploy a GPT model using Microsoft Azure. We will also be creating a logic app in which we will automate the process of ragging on ingested data so that we can create markdown and embeddings that we can index into the indexes with the fields that we have created. So if that is of interest to you, make sure that you follow along. And of course, if you have any development needs, make sure to contact Solve Systems at solvesystems.com so that we can help you out. All right. Okay, so before we get into creating the resource group itself, let's go over the composition of our resource group. So here we have a resource group composed of 6 different things. First one being Azure AI Studio. Azure AI Studio will be what we use to manage, deploy, and configure our different OpenAI models. The Azure Blobs storage here is what we are going to use to store our PDFs. In this specific use case, we are going to take PDFs from this blob storage and use them in a logic app where we will create markdown and embeddings to index into the indexes that we create in Azure AI Search, right? So blob storage holds all our different files. The logic app will automate this process for us, and Azure AI Search will provide us indexing and searching capabilities. This is all connected through different API connections that we define, and the GPT model will be provided from Azure OpenAI. So okay, before we get started, we need to set up some resources. The first one is going to be Azure AI Hub. I named this specific one Lulu AI Hub. We're going to put this inside of our resource group. We also need Azure AI Services. This one is named the same thing, but with some numbers behind it. And once we get those set up, we can go ahead and launch Azure AI Studio, and it'll take us to this web page. Here we have a hub overview where we see all the connected resources. This will have our different AI services, the OpenAI. We can also go into playgrounds and chat. Chat is where we can query with our models that we deploy. So in here, we can give the models context, instructions and context, and we can query right here. We can also select different GPT models and link our different data. In added data, we will link our indexes that we have created later on in this video. Under deployments, we can go ahead and deploy some models. I already have 2 here named Text Embedding ADA and GPT-4o. To deploy a model, you click Deploy Model and Deploy Base Model. Under here, you can choose whichever model you want. I chose this one and this one right here. These two would serve different purposes. The text embedding ADA002 will create our text embeddings in our logic app. We need the URI provided to us from this model, and we also need the key in our logic app. The GPT-4o model will also have a URI and key that we will use if we want to query our model from an API testing tool like Postman. We can also use this for querying our models in the playground. This resource, Search Service, which I have named Lulu AI Search, is where we are going to create our indexes. Once we have composed our document in our logic app, we are going to go ahead and index it into one of our specified indexes. Here I have created an index named Lulu example, but you can create an index here by adding an index, right? Here you can add the fields as you want it. If we go reference the one I have made and go under fields, we can see a couple of the fields that I have created. There is a default ID field that will be there. I have went ahead and created a content field in which we will store our markdown text, a title, date, and fiscal year. This will change depending on the data in your PDF file. And here is a content vector. The content vector can be any name, but pretty much what it will do is it will hold your embeddings for your GPT model. So once you have created your embeddings, when you compose your document, you're going to create a single collection field here, and in those embeddings, you will feed it into something called content vector or whatever you named this field. Here is a diagram of a more visual representation of what we are going to do. Here we have our Azure Blob Storage. In our Azure Blob Storage, we have to define some type of directory in which we will reference to code our files. These will be any PDF files that contain the data that you need to parse through. For this example, I am going to use a Lululemon financial report that I have found online. And we are going to take these documents and feed them through our logic app connected by an API connection, right? So these API connections connect all these resources and services together so that they can be used. So pretty much what the logic app will do is it's going to take each document in this directory and put it through a loop. And in each loop, we're going to take a document. So in this case, the first document here, we are going to use a API service called llama parse to upload this PDF. We're going to check if the status was successful. And once it is, we are going to produce markdown. This markdown will be used when we compose a document. Once we are done using llama parse, we then generate embeddings using the Azure OpenAI resource that we have connected to. This resource group will be connected through this curl command that we will go through in a bit. And once we have our embeddings and markdown, we can compose a document to organize everything in a uniform fashion and then index that document into Azure Cognitive Search. So Azure Cognitive Search is connected through another API call, and pretty much In this search, we will define an index with specific fields that this document will have to fill up. And once we have indexed it, we can then use it with our GPT model so that we can talk to it with GPT. We're going to start with the logic app. It begins with a trigger. This trigger can be anything. For now, I'm going to keep it as at an HTTP request to keep it simple. Here I have stored two API keys as string variables. I'm going to keep it hidden for now, but pretty much it is just a variable that stores the API key from this API that we are using, Llama Index. We also have an API key for our Azure AI Search, and I'll go over how we can get that API key in a bit. Our next node is going to be listing our blobs, which requires us to create a blob and connect it. So to create the blob, I went ahead and inside the resource group, we have created a new resource of a storage account. Under the storage account, we go under containers and create a new container. And this container named financial docs is where I am going to keep the different annual reports from Lululemon that I have sourced online. These are just PDFs of a bunch of different financial information from Lululemon. And so we are going to rag on this data and store it into our model. Right? And so under our logic app, we go ahead and list out the blobs. So in here, we have to specify after we have connected it. So first we have to connect it, and you can connect it using the access keys you can find here, right? So once you have created the proper connection, you can define the folder that you create, the container, so that this list blobs function knows where to look. Once we have done that, its output is going to look something like this, where I have, in this window, I have ran the logic app already so that I can show the example outputs. And it's in the body of this node, it's going to return an ID, a name, a display name, and a path, and all these different other variables, right? And as you can see, this is the first file in our report, and this is going to be in an array. So this array will contain every PDF that is inside that folder that we have defined. And so once we have this array of every PDF, so this is going to be an array of size 3, we can then parse through it and define the different formatting for it. And so in the content, I went ahead and dynamically included the represents a page of blob metadata under list blobs. And when we are parsing it, we can produce this schema by use a simple payload to generate the schema. We can go under what we have ran and copy the body from list blob and paste it in here. This will automatically generate the schema in which we will use. And as you can see, it creates all the little variables that we can easily reference now, right? Now that this is done, we have easy access to ID, name, display name. But since it's in an array the PDFs are in an array, we have to loop through this array so that we can access each individual PDF so that we can upload the PDF and create our embeddings and markdowns. So to do this, we run a loop. When we're running the loop, we're pretty much just running it through the whole array that we have generated under list blobs, right? For each, we're going to take the body value of our parsed JSON, which is just a formatted version of list blobs, right? So it's going to take the value of parsed JSON, which will look like this. Under parsed JSON, it will take this value. Oh, sorry. Yeah. Under parsed JSON, it will take a value, right? And then from there, we can use a body name. We can get the blob content by referencing the body name. So here you define the path to where your PDF is stored, and body name will be the name of your PDF. So pretty much this will be /financial docs / Lululemon 2021 annual report. In the next iteration, it will be /financial docs Lululemon 2022 annual report, and so on. And by doing this, we get the blob content of every PDF at every iteration of this loop. With this information, we can use it to upload our PDF. This is going to be the first API call using Llama Index, and we are simply uploading our PDF with this URI, right? It's going to use the authorization bearer token of Llama key that we have defined up here, and it's going to take these headers. In the body, it's going to take all of this, and the body here will be the file content that we produced from get blob content. So what this will look like, if we go under our ran instance, under get blob content, we are going to get this content string right here, which is just a long string of variables of random stuff. So once we have fed that into the body of this API call, We then do another loop. This is a do while loop or an until loop in Microsoft Azure. And we are looping until our check status here, which is another Llama index API call, returns success, right? So this is how you set up the HTTP request. It's going to be under this URI with the ID that we produced from upload PDF, right? So to reference again, upload PDF has these outputs and it has an ID and a status under their body. We are going to take that ID and we're going to feed it at the end of this URI. We are then going to we're going to authorize it with these headers and make it a GET request. And once that's set up, we are going to loop around this API call until it returns successful, because it's not going to return successful every time. We have to loop until it does, right? So in the until loop, we are taking the ID from check status, which is where it's going to return successful or not, and we're going to loop until it is equal to success. In this loop as well, we are going to produce our markdown results. Here is the URI call. This is the last one from Llama index where we are producing markdown. We are taking the ID produced from check status, right? Taking the ID from check status, which will look something like this. So under check status, it's going to show an ID and the status. The status at the end of this loop will be successful, but since it's the first couple iterations, here it is, success, right? Here is the ID. It's going to be fed into markdown results. Markdown results will then do the same headers and authorization to get our markdown. And the markdown is going to look something like this. Here's the markdown. It's going to be the data inside the PDF itself split up as a big string. So this is where we're going to feed into the content field of our index that we will create. All right. Next up, we are going to create our embeddings. Creating our embeddings requires a little bit of setup by our created OpenAI resource, right? So the specific one I have referenced is Lulu AI Hub, and it is when you create it, it's going to provide you a URI that you can reference, as well as the API key you have to use so that you can get the results you need, so that you can be authorized to get the results you need. In the body, it's going to take an input of the markdown file that you have created. The markdown will be defined as followed: the body of markdown results named markdown, right? So what that looks like is in our markdown results, it's going to output this body with markdown, right? This markdown is then fed into create embeddings, in which it will return a large list of embeddings, right? This is what our GPT model will use to index and search through things, right? So with those embeddings, we can then compose our document. This document, its format is highly dependent on the way you set up your index. In the specific index we have created, it's going to take an ID, a contact vector, the title, and the date. Make sure you are right. So the content itself will be the markdown text. The content vector will be our embeddings that we have taken from create embeddings. The ID and title are taken from parse JSON, and the date is just taking today's date and putting it in the format that the index accepts. So once we have finished composing our document, we can then index our document into our search AI. This specific one is Lulu's AI Search, and we just connect it like how we connected our blob storage, right? So we are connecting it, and then once it has been connected, we are giving it a name. We're taking the name of the index we created, which will specify where this document will be indexed into. Once our logic app has been run, we can see here that our Lulu example, which was the specified index that we wanted to index our composed documents into, has a document count of 3. So all 3 of those PDFs has been fed into Lulu example. So instead of using Azure AI Studio's playground to query your model, you can also use other API tools such as Postman to do the same thing. If we go inside of our deployments and open up the model that we have deployed, GPT-4o, we are provided with the target URI and the key. If we go into an API tool like Postman, we can start a new request. This is a post request that takes this URI as its URI, right? Under the body, we can specify data sources and messages. Data sources will be of type Azure Cognitive Search, and its parameters will be the endpoint. The endpoint is the name of our Azure Cognitive Search resource. For my specific case, is Lulu AI Search .search.windows.net. So this is appended to the end. The key will be this following key that is provided to you. The index name is the index that you have indexed in your logic app. For this example, it's just Lulu example. And under filter, we can specify different fields such as fiscal date, fiscal year, I believe it was, and we can make it equal to some value so that we can filter through different documents, right? I'm going to leave it empty for now. Under messages, we can give the context to our model. For this one, you are an AI assistant that helps people find information. And then here is what the user will query. So you can put in any query you want, and once you send this HTTP request, the return body will be the response from the model. So now that we have everything indexed, we can go back into our Azure AI Studio, and we can go ahead and go into all projects and create a new project. We can also do this under chat. And in chat, we can add our data, and then we can create or select a project. Once I already have a project made named video example, so I'm going to select that. And now we are loaded into a chat playground with this specific project. From here, we can go ahead and add our data, and we can add a new data source. In our data source, we can connect Azure AI Search, which is where our indexes are. And we can go ahead and select that, go next. We can select our service, which is the one that we created, Lulu AI Search, and we can select the specific search index, which is Lulu example. In our search settings, we can just go ahead and leave this as default and leave this as default as well. And we can go ahead and create our data. All right, so now that that is created, we can go ahead and mess around in the playground. We can give context to our model. The generic format, the default format is you are an AI assistant that helps people find information. You can also add parameters like you are a financial analyst, only provide the percentages of the data that you return. But we are going to leave it as default now, and we are going to use some queries. So here is an example of our chat playground with a query. I just told our model that we have ingested data into and that we have connected here to add our data to give us financial information. The data that we have been working with has been 3 PDFs of annual financial reports from Lululemon. So the response is going to be the 3 years representing each of the PDFs and all the different data it was able to procure from our indexes because we were able to feed it different embeddings and different markdown. All right, that's pretty much it. If you guys need any other help with your development needs, please make sure to contact Solve Systems and we would be happy to help.